All right, so I got this great question here about how we make an equation from looking at a graph. And here's kind of a quick rundown of what we're looking for. To create an equation from a graph, you look for key characteristics like one, what's the style of the graph? That's important, aka this is the parent function. It allows us to understand which graph we're working with, and what I mean by that is it linear? Is it an absolute value? Is it a quadratic, a square root function, an exponential function? Those are four of the six that we've learned thus far. That's what we look for first. Second, what is the y-intercept, specifically for linear functions, or mainly for all other functions? I'm going to highlight this here in red. What's the vertex? Because the vertex tells us kind of that lowest point or starting point for some of these graphs. Just to say it kind of simply, effectively that vertex tells us how the graph starting point or lowest point has moved horizontally, which we called with our variable h, and vertically. Effectively, the vertex for all of these values are simply your h and your k in our transformation template. So that's what we're going to look at, and I've created a few different quick graphs here to look. I'll just kind of work with this, and this one real quick here, you could see is a linear function, so that's what we look for first. We see that our y-intercept is at 4. And then we can look for other key characteristics like the slope on this one. We know that we want to put this in slope-intercept form. So our y-intercept is at 4, and it looks like our slope is going down 2 over 1 to the left. So for this situation, we'd say, all right, first equation, we know it's a linear equation, y equals mx plus b. From our graph, we interpreted that our y-intercept was 4, and then we figured out through using our eyes or counting that our slope was down 2 over 1 or negative 2x plus 4. All right, next function. Sorry about that. Just look at this one. Okay. We can see here that this is a downward shaping U, so this is one of our parabolas or our quadratics. So very first thing that we wanted to do was style of the graph. This is a quadratic, which means our parent function for this is y equals x squared. So our transformation template is going to be y equals a times x minus h squared plus k. Again, notice here that the x squared is still present in the template. Now we're just throwing the a, the h, and the k to talk about those shifts, reflections, and stretches. Cool. So now we're going to look for the vertex of this. Our vertex is going to be this point right here, okay, which to me looks like it's at negative 1, 3. So our vertex is at negative 1, 3, and again, that's our h and our k. So all I'm going to do is I'm going to bring this purple equation, y equals a times x minus h squared plus k, and then replace my h with negative 1. Just a little substitution, because we know that's where our horizontal shift, it went 1 to the left, and our k with positive 3. Let me get these arrows out of the way so it doesn't look all that confusing. But again, just replacing, highlighting in blue, the h with negative 1 and the k with positive 3. Sweet. The last thing that we need to do here is look at our graph and say, all right, well, we know typically a standard parabola, a parent function parabola, you can see the equation right there, by the way, but we'll come back in a second. And the parent function of quadratics looks as follows in purple. So obviously the origin got shifted up and to the left, 1 to the left and 3 up, hence why our h, k is negative 1, 3. And it also got reflected, so we know the reflection deals with that value right there. That tells us reflection. So since this is reflecting over the x-axis, a fancy way of saying that is basically it's opening downwards instead of upwards. This a value has to be negative. And in this case, because it's not being vertically stretched, it is just a negative 1. So final situation, to create this equation from this graph, we have y equals negative 1 for a, x minus a negative 1, minus a negative is the same thing as plus positive 1 squared, plus our k value of 3. Now we're going to see if that is indeed the equation that I had written. And look, It sure is. If you look at the top left-hand corner of the screen here, we have y equals negative 1, x plus 1 squared plus 3, which is negative 1, x plus 1 squared plus 3, money.